Okay, so today a little bit change of plans here. I'm going to post this short video here going through the notes, the eclipses of what we would have done today. We actually would have get a lot further than we do today, but that's okay. We'll pick up here with it tomorrow in class. So today what you're going to do, you're going to get your notebook out. You're going to take down a few notes on eclipses, and then that way you can start to do the worksheet or the assignment there and go formative. It's not really a worksheet; it's just an assignment. A couple questions there for you to think about here, and then we'll have some videos to watch showing what these are. Eclipses is one of our vocabulary terms. Remember, vocab quiz tomorrow in class on your moon vocabulary and basically the second side of that vocabulary sheet. All right, so what are eclipses? Okay, the word eclipse means to block, okay, and in this case, we are blocking the sunlight. Eclipses occur when the shadow of one celestial body, okay, so this could be anything. This could be a planet, this could be a moon, this could be an asteroid, anything that is up in space that casts a shadow, and everything does, okay, anything that has any kind of size mass does cast a shadow. What that shadow actually hits depends on how big the shadow is. What this would happen would be similar to you blocking light from a lamp with your hand. Okay, so the further you are from the lamp, okay, the smaller your. I'm sorry, the closer you are to your face, for example. If you put your hand up and you shade the light that's coming down, okay, the further your hand is from your face, the shorter that shadow actually is, the less light you'll actually block out. When you get closer to your face, the shadow gets a lot darker because the shadow actually falls on your face. And this is kind of what happens in space. The closer an object is, the more likely the shadow is to hit the planet. In our case, Earth, because that's where we're at, and the more likely that shadow is to hit the Earth itself. The Earth and the Moon cast deep shadows into space, really, really big, because they are very, very large. Now, obviously, we know the Earth is larger than the Moon, therefore, the Moon casts a much smaller shadow than the Earth does. So, the Earth shadow, very, very large. The Moon shadow, still very, very large, just not as large as the Moon shadow. And as we talked about, and makes sense to us, the sun casts no shadow. Why? Because it's lit. So does every other star that's lit up. They cast no shadow. There are two parts to every shadow, okay? So there's a part of the shadow where the light is completely filtered out or blocked out. That's called the umbra. It's like complete or ultimate darkness. And the opposite would be penumbra. When we went over these as vocabulary terms, I said penumbra is kind of nice. It starts with a P, so you should remember partial. Not all the light is blocked out in this case. This is what it looks like, okay? A little drawing of what this actually looks like as you move further away from the object. So here's the sun itself, okay? So the light comes from the sun. As we move further from the object that's casting the shadow, the umbra will get smaller, but the penumbra will increase. That would be the partial part here, this part that's light gray. Eventually, though, this shadow stops. It's just like your shadow that you cast on the ground. Eventually, that shadow stops, and then the light filters all around in that shadow. A solar eclipse, okay, and I've got two little stick figures drawn here, which I left those guys on here because I wanted you to be able to see them. A solar eclipse is when something is blocking the sun. Remember, we talked about this. We are always on the earth. Because we're always on the earth, okay, it's got to be something else that's blocking the sun. And it can't be Earth. It's got to be the moon. And we can see in this picture the sun very, very large. This is not to scale. The sun would be even much, much larger. And we can see the moon very, very small. And then we see the Earth. Okay, so once again, not to scale. Okay, the Earth would look like a little pinpoint next to the sun. And then the moon, we wouldn't even be able to see it at all. At any rate, if you look at this, okay, and this is a good depiction, the moon is pretty far away from the sun compared to the Earth. Here's the depiction. Only people, this is where the stick figure comes in, only people that are in this area of the Earth, wherever this shadow hits, whether it's green or purple, are going to see an eclipse. If they're in the purple, they're going to see what we call total solar eclipse. If they're in the green, that's when they're going to see that partial solar eclipse. We saw this in 2017. If you're down here and this band of shadow never makes it there, then this person down here at the bottom is never going to see a solar eclipse. You can pause the video here and watch the solar eclipse video, or you can continue here and then watch the solar eclipse video afterwards. So what's the difference? A total solar eclipse, okay, the observer would have to be in the moon's umbra. The umbra is very, very small because the moon's size is very small. So this would only last for a few minutes, okay? It's called totality, when the moon completely covers the sun, okay? And you can see this glowing aurora. The moon will completely cover the sun, and it has to be the proper distance away, okay, because we're going to talk about next what happens when it's too close to the sun. So the moon completely covers the sun. This is a process. So the moon's going to come on just like you saw in the video, and it's going to keep coming on there, and then it's going to cover this completely, and you're going to see what they call Bailey's beads. At the last sliver of light disappears behind this, and then all we'll see is what's left of the corona. This is the outermost layer of the sun, and only visible during a solar eclipse. This is something you absolutely would not want to look at without filter glasses. And many places around the world give filter glasses out when eclipse is hitting us. So in 2024, it's going to be a pretty big show, and we'll talk about that here in a few minutes. In a partial solar eclipse, the moon never completely makes it across. So here the moon, the umbra, doesn't hit this particular place where we are, so we only see the partial. This moon would have to continue on down, but instead, in this instance, the moon is just going to kind of sideswipe the sun. Very, very dangerous to look at with your naked eye because this is going to be very, very bright. So you, the observer, would only be in the moon's penumbra. Penumbra partial, that's what we need to think there. Only see part of the sun covered by the moon, and it will never keep going, okay? This is all the more that you would see, just depends on where you're at in that penumbra. The last type of eclipse would be called an annular eclipse. An annulus is a ring, all right? So it's a geometrical shape called a ring. What ends up happening here, like I said, the moon is at the furthest point away from the Earth in apogee, but it's at its closest point to the sun, and it's too small to actually completely cover the sun. So this black spot here in the middle of this ring, this is the moon, and it gradually moved over there. Instead of covering the sun completely, it's too far away from the Earth. The umbra stops before it hits the Earth, and we only see what's called this annulus. And as you can expect, an annulus eclipse is even more rare compared to a solar eclipse, which is pretty rare in itself. Because the moon is very, very small, and the moon is very, very small, and it's also orbiting on a different plane compared to the Earth going around the sun. And we'll talk about that more tomorrow. The next total solar eclipse will happen on April 8th, 2024, and this is in the continental United States. Alaska and Hawaii see their own separate eclipses because they're so far from the United States. Have a little picture here. This top path here that's running from the northwest to the southeast is the eclipse that happened on August 21st, 2017. This was the first day of school. So only those people that were in this blue band saw the total solar eclipse. What did we see up here in Pittsburgh, Pennsylvania? Well, we saw a partial solar eclipse. You can see these other bands. Obviously, we're not going to see anything up here on 2024. You see one in August 2008. None of these guys were anywhere close to us. In 2045, you will be able to travel south yet again. Most of Florida will see this, and this would be August 12th. So, but by then, you guys will all have families probably of your own, and you can talk to your kids about this. The next one for us is going to be April 8th, 2024, and you can see how close it goes to Pittsburgh. We would just have to go slightly north up to Newcastle area to see the total solar eclipse, but we're going to be in the penumbra for a long period of time there. But that one's going to be a big one. It takes a pretty big path across the United States. The opposite of a solar eclipse will be a lunar eclipse. Lunar eclipses occur when the Earth comes between the sun and the moon. So lunar is we're not seeing the moon. What is blocking them? The moon reflecting the light from the sun to us is the Earth. Okay, so the moon itself is in the Earth's shadow, and it may appear red because the atmosphere of the Earth will actually filter out all that blue light, and it absolutely does. Filters out all that blue light. And this is what it looks like, okay? Still seeing that moon, those same parts of the moon, okay? Just so happens that the moon is being covered by the Earth's shadow, and it appears red because of the atmosphere of Earth. And there it is. All right. This is where we're going to stop today because I want to go through this guy tomorrow with us and we can talk about the show and stuff like that. What you're going to do is you're going to go ahead and end this. You're going to log off and you are going to answer the questions on the formative, okay? Once you finish with the formative, then there are 2 study island assignments that you will need to complete. You have until the end of the period to work on these guys, okay? If you finish with both, you get a 70% or higher, then you're free to work on other things as long as your Go Formative is submitted. So first, you're going to log on to the link on the Google Classroom for the Go Formative, complete the formative. Remember, your homework for tomorrow is to study for quiz, and you have 2 study island assignments that you can use the rest of the period to work on that are due tomorrow as well. All right, folks, that's what I have for you. You guys have a good day, and I'll see you tomorrow. Study for quiz.